Okay, today we're going to be applying some of the solving quadratics work that we've been doing. So notes number 5, quadratic applications. I want to kind of flip back and forth between the work we're doing and also just kind of show this graphically, which is where we're moving next. So looking at this first one, it says an astronaut on the moon throws a baseball upward. The altitude, the height of the ball in feet, X seconds after he throws it is given by this equation. And it says, at what time is the ball 12 feet above the moon's surface? Give your answer to the nearest tenth. So we are going to need to use a calculator here because we're going to have radicals that we're actually going to, we want the decimal answer at this point because it wouldn't make sense for me to say like, well, it'll be in, square root of 5 seconds. That wouldn't make sense in the context of the problem. We want the decimal answer of that, like 2 point something seconds. So just kind of as a reminder that the graphs for our quadratics, and I've drawn them a few times, either look like this, okay, so a parabola that's opening down or a parabola that's opening up. A lot of the applications that we're looking at will be this, and the negative out front is actually what's causing it to open down, where something's going up and it's coming back down. Okay, throw up a basketball, it comes back down. We throw up this baseball, it's going to come back down. And what this particular problem is telling us is that the y-axis, so there's going to be some kind of up and down that will happen, that the y-axis is height. So this is our h is going to be our y, and then we have x, which is seconds. So here's how many seconds it'll be. So here along our axis, we'd have 1 second, 2 seconds, 3 seconds, for however many seconds it's going to be out. And then our height, meaning our vertical height straight up and down. And sometimes the equation may have different meanings for the variable. So sometimes the y is height, the vertical height, and the x is the distance, the horizontal height. So we have to pay attention to what the equation is, what the context is. So we have seconds and height here. And we want to know when the ball, and so I'll just pretend that this is 12, when is the ball 12 feet off the ground? Okay, when are we 12 feet off the ground? Okay, so not when it hits the ground, but when are we 12 feet up? And so I just want to show you a graph here. So I have up a Desmos graph of this function. So here's my function. Let me zoom it out a little bit more. There's my x-axis and here's my y-axis. And so you can see it's going up and back down. And we want to know when, you can see this is 20 feet. At what time are we going to be 12 feet above the, maybe that's not 20 feet, right? that's weird. Oh no, it is. I'm looking at my y. So 12 feet on my y. So let's see. So we can kind of scroll along here, get a little close, right? We're seeing that's about 10 to 11 seconds. We're going to hit that mark. Now we want to use our solving to get this exact. So let me go back to my screen. Hopefully that gave you just kind of a preview of what we're doing, making some logic of what's happening here. Now we want 12 feet above the ground. Remember, h is the height of the ball. So 12 feet above the ground means we're going to make our height be 12. H is 12. So I'm going to take my function here and substitute 12 in for height. Okay. And then in order to solve this, first of all, we know we're not using square roots because we have a variable term that's in more than one spot. Okay. So we have to use factoring or quadratic formula. So in order to use either of those methods, we need to get this set equal to 0. So the next thing I'm going to do is I'm going to subtract 12 from both sides and get my equation set equal to 0. So then I'll have negative 2.7 x squared. 1 minute. Plus 30x. And now we're going to have negative 5.5 for my c value here. And I could clear fractions if I wanted to, but because we're going to use a calculator, I'm just going to go ahead and substitute this into our quadratic formula. So I'll have x equals negative 30 plus or minus the square root of 30 squared, so is going to be the same as 3 squared, but we're going to add some zeros in there. It's going to give us 900 minus 4ac all over 2a. Okay, so I substitute into my quadratic formula, really careful there. And then I'm going to use my calculator. And so I have a graphing calculator, but a scientific calculator is fine. And what I'm going to do is I'm just going to type in everything underneath this square root to simplify it. So I'm going to have 900 minus 4 times a, and just being really careful with negatives, right? So it's negative 2.7 and negative 5.5 is going to give me 840.6 underneath my square root, and 2 times negative 2.7, giving me negative 5.4. Okay, so now I'm at the point that I can simplify. Now we want to be really careful with one particular piece with our quadratic formula here, and that's that the entire numerator is being divided by negative 5.4. So we have to be careful with how we type it into the calculator. And I can give you a few suggestions on how to make that easier. But if I were to just type in this, so let me just show you. If I typed in negative 30 plus the square root of 840.6, okay? And then I just clicked divide by negative 5.4. If that's how I typed it in, it's not going to give me the correct answer because the calculator is going to do order of operations here. So it's going to divide first. It's going to divide this rad by negative 5.4, and then it will add negative 30 in. Okay, so we don't want to type everything in at once. What I do is I type in the numerator, so negative 30 plus the square root of 840.6, and I hit enter. Okay, so there's my one of my numerators, negative 30. If I add that square root, I get negative 1.01, let's call it, over negative 5.4, okay? If I do negative 30 minus the square root of 840.6, I get, and I'm just gonna round, negative 58.99 over negative 5.4, okay? And now I can go back in and type it. Another option is if you're using a graphing or the scientific calculator, I can from here, okay, so I already have I have this one up, just hit divide and it's gonna pull this answer down. And that way I don't have to use the rounded result at all. It'll be a little bit closer. And this gives me positive 10 points as round to the nearest tenth. So we'll say 10.9 seconds is one answer. The other answer, negative 1.01 divided by negative 5.4, is giving me about 0.2, rounding to the nearest tenth seconds. Now, why are there two answers and one's not negative? Well, if we think about our graph again, and let me share the graph one more time. Remember, the ball's going to go up and it's going to come back down. So because the ball's starting at a height that's less than 10 feet here, it's starting at 6.5 feet when it's at 0, and then it's going to be in positive values from there on out. That it's going to hit 10, and I can actually show you in here. If I type in when does y equal 10, it's going to hit, I'm sorry, not 10, 12 feet. It's going to hit 12 feet at 2 points. Okay, so here's my 10.9, and then this is probably just rounding down, so it's not quite at 0. We know it's 0.2, but it's close enough that they're calling it 0, just like they were calling 6 0. Both of those points are not, they're not both there. It's just rounding a little bit more. There it is. There we are. There's our correct answer. Okay. And so we are at 12 feet at 2 points. Now, sometimes we do have a negative value and then a positive value, and we want to take the one that's positive. But it's at 12 feet at both 0.2 seconds and at 10.9 seconds, and rounded to the nearest tenth. I want to skip down to the last application, and then we'll look at the two in the middle. Last application is similar to the first one. Now, what's trickier about this problem is that, oops, you can't see my screen. Hold on. is that we have to input the values. So let's kind of highlight what we're given here. There's fireworks. Okay, so we shoot the firework up at an initial velocity of 125 feet per second from a platform that's 3 feet above the ground. And we want to use this model, okay, where, and it tells us that V is the initial velocity. So I need to substitute in initial velocity is 125. I need to substitute that into my equation. And S is the starting point. Okay, so S is where we're starting from. So I need to substitute in for VT. I know my initial velocity is 125 T. And I know that S, my starting point, is 3 feet. Okay. And then it says H is the height and T is time in seconds. So just like our last one, we're going to have something go up and go back down. And this is my height. Okay, vertical up down height. And this is how many seconds has passed when the firework is at that point. Okay, so how many seconds has passed when it's here, how many seconds have passed when it's here, and so on. Okay, and this is how long will it take the rocket to hit the ground. So for this one, we will have a positive and a negative. Okay, hit the ground means how long will it take till it gets here? We're going to want this answer, okay, on that side of the graph. It's going to go up and come back down and hit the ground. And at this point, hit the ground means we have a height of 0, okay, that our height is going to be 0. Okay, and again, I can, if we could take out a GCF, sometimes these problems are factorable. If I could take out like a negative 16, sometimes they're all divisible by 16, and sometimes we can factor and solve these problems. But I'm going to use the quadratic formula here. X equals negative b plus or minus the square root of, I'm just going to leave it as 125 squared for a moment, minus 4ac all over 2a, 2 times negative 16, giving me negative 32. And I'm going to let the calculator do that work underneath the radical for me. So 125 squared minus 4 times negative 16 times 3. So I have negative 125 plus or minus the square root of 15,817 over negative 32. So definitely trickier numbers to work with, right? And so I'm going to get two solutions here. One, I'm going to add my radical in and then divide by negative 32, and the other I'm going to subtract. And again, remember, we have to be really careful that we're dividing the entire numerator by negative 32. So if I have negative 125 plus the square root of 15,817, enter, divided by negative 32. Okay, so that's going the first way, negative 125 plus this rad divided by negative 32 gives me negative 0.02. Going the other direction, negative 125 subtract the square root of 15,817 divided by negative 32. Okay, so notice I typed the whole numerator and got the answer, then divided all of it by negative 32, gives me 7.8. Okay. Now this answer would be the one that's over here. That's the one we don't want. We want this answer, and we'd use units, our seconds. It would be 7.8 seconds before that firework hit the ground. So we shoot it off, it's going to go back down and hit the ground at 7.8 seconds. And again, we could look at the graph of this. So if you ever need to pull up Desmos and look at the graph, certainly you can. My function was h equals negative 16t squared plus 125t plus 3. And we wanted to know, let me zoom that out so you can see the parabola there. May not be able to. Oh, I have a negative, that's why. There's my, goes up, comes back down. I can zoom this back in a little bit. Okay, goes up, comes back down, and it hits the ground. And hey, look, there's our answer at 7.8 seconds. Okay, that's when it's hitting back down on the ground. Okay. Now let's look at the other two, and the other two are going to use different solving strategies. So we use the quadratic formula for those velocity problems. Now let's look back at these middle two applications. So first one has Bob in making a quilt that's 4 feet by 5 feet. He has 10 square feet of fabric that he can use to add a border around the quilt. How wide should he make the border to use all the fabric? The border must be the same width on all 4 sides. Okay, so we have this quilt, straw quilt, that's 4 feet by 5 feet. And we want to add a border, okay, that's consistent all the way around. Okay, that's the same distance on all sides all the way around using this 10 square feet of fabric. So we need to figure how can we set this up using quadratics. And we did something similar to this. I'm going to say it was a swimming pool back in our factoring unit. So we're adding the same amount on both sides. I'm going to call that amount X, which means this new quilt, once we have the border, that this length would have 2X plus 5. It's going to have border amount on both sides and then 5 feet in the middle. And this side is going to have 2X as well, plus the 4 feet in the middle. Now, the area that we know is that we want to use is the area of the border. So the area of the border, which we can find, which we can write an equation for by taking the total area of the new quilt and subtracting the inner rectangle of the 4 by 5 rectangle that's in the middle, okay? So if I look at this entire quilt now with the border on, that total area being 2X plus 4, right? Area is length times width. So we have 2X plus 4 times 2X plus 5, that's our total area. But if I want to just look at this strip around here, we're going to take that total area and subtract the 4 by 5 rectangle that's in the middle, or the 20 square feet that's in the middle, right? This middle square or rectangle is going to be 20 square feet. And that will equal the 10 square feet that we want to use for our border, okay? So we know we have 10 square feet of fabric. That's how I have that value. My total area, I created my expressions using this visual here. And I want just the border, so I'm subtracting out this rectangle in the middle. So now let's multiply this out, giving me 4x squared plus 10x plus 8, so plus 18x plus 20 minus 20. Okay, so I have 20 here from in the middle and 20 from the 4 times 5 in my polynomial multiplication there. So these are going to cancel. Now, in order to solve this, I have to get it set equal to 0. So now I subtract the 10 over. And here's my quadratic that I'm going to try to solve. One thing I notice is that I have a GCF, right? So next, I'm going to take out a common factor of 2, leaving me with 2x squared plus 9x minus 5. Now, if I can, I'd like to solve this with factoring. If not, we'll use the quadratic formula. We know that we can check that using our b squared minus 4ac. So I could do a real quick, b squared is going to give me 81 minus 4 times a times c, which I can type into my calculator even. Giving me 121. So yay, we can factor this. Or you could have just tried to factor and see if it works. Like I could see it just kind of looking here, how I could combine 2 and 5. So factoring this, and I'm running out of space, I'm going to get 0 equals, still have that GCF out front, 2x and x, right? And then 5, if I want this to be 9, I want my 5 here, positive 5, negative 1, giving me 10 minus 1, or 9 for my middle term. So here are my factors. Okay, so we had to use a quadratic formula on 1 and 4. Here we're able to factor and giving me the solution of 1/2 and -5. Now, here's our application problem. So it says, how wide should he make the border to use all the fabric? Well, we wouldn't say -5. We want it to be 1/2. Now, there's two ways we could answer this. Our units are in feet. So I could say 1/2 foot, or I could say we want a 6-inch border all the way around. Okay, either one would make sense. I think 6-inch border all the way around would make a little more sense when you're describing what you're going to do with this quilt so that I use all of that fabric. Okay, so again, this goes back to our factoring unit, not so much the new stuff we've done this time around. Let's look at our last application problem here. So it gives us a new formula, an area of a circle with radius r is given by this formula, a = pi r squared. It says if a circle has an area, okay, so the area is 81 pi, I can substitute in 81 pi for the area in my formula here. Okay, so the area of my circle is 81 pi. We want to know what is the radius. This goes to solving using inverse operations. So if I want to know what the radius is, here's my variable for radius. I'm going to divide by pi on both sides, cancel it out, and I'll have r squared = 81. And I can just take the square root of both sides, giving me ±9. Now, our radius is not going to be negative. Okay, so our radius is going to be 9 inches. Okay, quick little application problem using inverse operations instead of quadratic formula or factoring to solve. So you'll get some practice with this on our quiz review. I want you to only do the first 6 problems. Notice that on the first 3, it gives you the same equation that we did on the last problem here. And you have to plug in your velocity and your starting height and then go from there. Some of these are factorable. Some of them you'll need to use the quadratic formula. And then it continues from there. It has some application problems that use other things like factoring and inverse operations to solve. Okay.